Hi, today we're going to talk about how to subtract integers. In order to subtract integers, what we want to consider is what's called the additive inverse. What does that mean? What does it look like? Well, here's an example of how to understand what additive inverse means. In the problem 5 minus 3, if we were to use the bubble to show this problem, we would take 5 positive signs, and then we would subtract or erase 3 of them. And so then that would leave us with 2 positive signs left over. Okay, so now what we're going to do is we're going to take a look at that a different way. Again, let's start with 5 positive signs. Now, what would be another way that we could end up with 2 positive signs left over? We know that 5 minus 3 is equal to positive 2. So what could we do to this bubble in order to get 2 positives? Well, we could add 2 negatives to our bubble, and then that way, when we pair them up, positive and negative, we end up with 2 positives left over. And so you end up with the same thing. So 5 minus 3 is the exact same thing as saying we take 5 positive signs and then add 3 negatives. This is called the additive inverse. Another way to think of using the additive inverse is to use what's called SAO. And maybe your teacher last year may have called it same, change, change. Well, I like to use SAO. And so I'm going to show you how to subtract integers using SAO, which is really just using the additive inverse. So, for example, in problem number 1, we have negative 8 minus 13. Since this is a subtraction problem, we can use SAO. The S goes with the negative 8, the A goes with the subtraction sign, and the O goes with the 13. So thinking of additive inverse, what this means is we're going to keep the negative 8 as negative 8. We're going to change our subtraction to addition, and then the opposite of 13 is negative 13, just kind of like using the bubble. Now we can use our adding integer rules that we've learned before. Negative 8 plus negative 13 is negative 21. Let's do the same thing for number 2. We have a subtraction problem. So if we use SAO here, the S would go with the 4, the A would go with the subtraction sign, and the O would go with the 10. So we'd end up with 4 plus negative 10. And using our adding integer rules, we know that there are more negatives than positives, and there are 6 more negatives. Problem number 2 is actually a special problem, though. If you take a look at these problems that I'm going to list here, 4 minus 10, 6 minus 13, 8 minus 15, you might notice that all of the first numbers are smaller than the second numbers. Now, on the flip side of that, if I were to reverse all of these problems, 10 minus 4, 13 minus 6, and 15 minus 8, now I have all the larger minus the smaller. So what type of answer do I get when I take a big number minus a smaller number? I get positive answers. So what do you think is going to happen if I were to reverse the order? 4 minus 10, 6 minus 13, and 8 minus 15? I'm going to get negative answers. But notice the number part of each answer is the same as the number part over here. So it's kind of like a little trick. If you notice that you have a small number minus a bigger number, then what you want to do is just subtract them. 20 minus 10 is 10. And then we say, since 10 minus 20, that's going to go below 0. So we end up with a negative answer. Okay, let's go ahead and try a few more. Number 3, 9 minus 16. If we think of this one like the last couple problems that we talked about, we could really just do 16 minus 9 and then make it negative because it's a smaller minus a bigger number. So we get -7 as our answer. Now on number 4, this is not the same type of problem as number 3, and so we're going to use SAO for this one. Let's rewrite this as an addition problem. -5 stays the same, and then we're going to change the subtraction to addition, and then the opposite of 11 is -11. Now we have just adding integers. -5 plus -11 is -16. All right, let's take a look at number 5. Same thing here. We're going to use SAO. The S means that the 7 is going to stay a 7. The A is going to change to an addition sign. And the opposite of -3 is +3. So this ends up being 7 plus 3, which is 10. Now I'm wondering if maybe your teachers in the past have given you kind of a trick to use when you have a minus and a negative right in the middle next to each other. Some kids say that their teachers tell them that if you have a minus and a negative sign right next to each other, that you can just make them into one big plus sign. And that is the truth. I like to call it the big plus. Or, if you prefer not to say big plus, I also like to call it the bloop bloop method. So if you have a minus and a negative in the middle of the problem and right next to each other, you can just bloop bloop and make it into 7 plus 3, which is 10. All right, let's go ahead and move on to number 6. You may notice in the middle of number 6, we have a minus and a negative right next to each other. This looks like a bloop bloop situation if I've ever seen one. So what we can do is we can change this minus and negative in the middle into one big plus sign. And then we use our adding integer rules. -2 plus 4 is 2. Moving on to number 7. 12 minus -4. Once again, we have a bloop bloop in the middle. Now, if you don't recognize that you have a bloop bloop situation, you can just use SAO and it ends up being the same exact thing. Watch. S means 12 stays the same. Change the subtraction to addition. And the opposite of -4 is +4. See? Bloop bloop ends up being a plus. 12 plus 4 is 16. Okay, and the last one here, number 8. When you have more than 2 integers, what I would recommend you do is first solve the first part of the problem and use SAO if you have to. So if we have -4 minus 2, that is a SAO problem because it is a subtraction problem. So if we have SAO, this is really going to be -4 plus -2. So let's go ahead and figure out what that equals. -4 plus -2 is -6. Now I need to deal with this -17 at the end. So once again, I'm going to use SAO here, and I end up with -6 plus -17. I'm sorry, that's a little bit hard to read. Let's put that over here. And so then when we combine these, we end up with -23. All right, you're doing a great job so far. Let's finish up this lesson here with numbers 9 and 10. On numbers 9 and 10, we're now using variables, and we have to substitute in our numbers for our variables. So in number 9, if we have b minus a, really carefully we're going to think about that, because if I substitute in 8 where the b is, and then I bring down that minus sign, then I have a, and a is -3. Here I have a bloop bloop, or I can use SAO because it's subtraction, and I end up with 8 plus 3, which is 11. All right, now let's do number 10. Number 10, we have c plus a minus b. C is -9. Then we put the plus sign. Then a is -3. And then we put the minus sign. And then b is 8. So just doing one thing at a time here, negative 9 plus negative 3 is negative 12. And then I have the minus 8 to bring down. Now, this is a SAO situation because I have subtraction. A really common error is for kids to accidentally use SAO here, but see, that's not a subtraction problem, it's an addition problem. So you just use what you know about adding integers. Once I use SAO on negative 12 minus 8, the negative 12 stays the same. I change it to addition, and then I take the opposite of 8, which is negative 8. So in the end, my answer ends up being negative 20. Okay, now it's your turn. Enough watching on your part. Pause this video, go ahead and try numbers 11 through 15, and then play the video to check your answers. Okay, let's go ahead and check and see how you did. So for number 11, we are going to use SAO here. So negative 13 stays negative 13. The subtraction changes to addition. The opposite of 9 is negative 9. Negative 13 plus negative 9 is negative 23. Number 12, 15 minus 23, I'm noticing that the first number is smaller than the second number, so I'm just going to subtract in the reverse order, which is 8, and then make my answer negative because the smaller number is first. Number 13, I see I have a bloop bloop right here, so I'm going to change this into a big plus sign. 21 plus 4 is 25. Number 14, I can either use SAO or I can do bloop bloop because I notice in the middle I have a minus and a negative. This would be negative 9 plus positive 12, which is 3. And last but not least, negative 7 minus negative 8. I can bloop bloop right here in the middle, so my problem ends up just being negative 7 plus 8, which is positive 1. Way to go, way to stick through it. If you are making a foldable for this lesson, go ahead and fill in the section on subtracting integers. Make sure you explain what SAO is, how it means same, add, opposite, and then also make sure to include something about bloop bloop or big plus when you have that minus and that negative in the middle. And that's the end of the lesson. Have a great day, everybody.